This module is calculating mole conversions using the IDEAS self-management strategy. This is movie 2. What is a mole and who is Avogadro? Now, what is a mole? Although this animal is a mole, it's not the type of mole used in chemistry. In chemistry, when people talk about mole, they are referring to mole as a counting unit. A mole is used in science to talk about extremely large numbers of extremely tiny countable objects, such as molecules, atoms, or electrons. Objects which are obviously way too small to see. We use the unit mole just like we use the unit dozen or the unit pair. 1 dozen equals 12 of something, like a dozen eggs. 1 pair equals 2 of something, like a pair of shoes. The unit we'll be focusing on now is mole. In chemistry, 1 mole means 602 sextillion 200 quintillion of something. Of course, it's easier just to write it as 6.02 times 10 to the 23rd. 23, or to the 23rd, means to the 23rd power, or something multiplied by 10, and then multiplied by 10, and then multiplied by 10 again, and, well, you just end up saying, and then multiplied by 10 again, a total of 23 times. Okay, get your response paddles ready. True or false? Teachers, get to where you can see. A mole is a counting unit. Paddles up. That's true. A mole is a counting unit. Paddles down. A dozen is a counting unit. Paddles up. That's true. A dozen is a counting unit. Paddles down. 1 mole equals 1 dozen. Paddles up. That's false. 1 dozen is 12, and 1 mole equals 6.02 times 10 to the 23rd. They don't equal each other. 1 mole equals 6.02 times 10 to the 23rd. Paddles up. That's true. Paddles down. 10 to the 23rd means to add 10 plus 2 plus 3. Paddles up. That's false. 10 to the 23rd means to multiply by 10 and then multiply that answer by 10 and then do that 23 times. Paddles down. One mole is so big that it is very easy to see. True or false? Paddles up. That's false. Okay, let's talk about who Avogadro was. Let's get his picture up there. He's a handsome guy. Let me see. Today it's easy to define atoms or molecules, but in the early days of science, there was disagreement about the definitions. Avogadro was a lawyer and a physicist who lived in Italy. He was born in 1776. Around 1811, Avogadro hypothesized that equal volumes of all gases at the same temperature and pressure contain the same number of molecules. When water boils and becomes water vapor, a molecule of oxygen splits into 2 atoms. Avogadro's hypothesis was key to solving many problems facing the chemical sciences in the 1800s, but scientists did not believe his hypothesis was true. Again, there's that disagreement. After Avogadro's death, scientists realized his hypothesis was true. Chemistry would be very different today if it were not for Avogadro's work. Avogadro's number is 6.02 times 10 to the 23rd. Now, this number was not discovered by Avogadro, but because of his contribution to molecular theory, the number was given his name. Now, how big or small is Avogadro's number 6.02 times 10 to the 23rd? The size of Avogadro's number is very hard to understand because a mole is so small. And Avogadro's number of soft drink cans would cover the whole Earth and be 200 miles deep. If you had Avogadro's number of unpopped popcorn kernels and spread the kernels across the United States of America, the country would be covered in popcorn over 9 miles deep. Amedeo Avogadro's work wasn't recognized until 2 years after he died. A friend showed how his work could be used to solve many of the problems of the day. Now, how would you feel if you discovered something, but no one gave you credit for it until after you were dead? Imagine how Avogadro must have felt. A mole of eggs would fill all the oceans on Earth more than 30 million times over. Think about how small something would be if you needed to count it by the mole. If the idea of a mole was never used, we would never know the amount of chemicals to react to make things like paper, computer chips, gasoline, or soda. The gray box identify mole equalities. There are 3 mole equalities used in calculating mole conversions. You've just learned about 1 mole equals 6.02 times 10 to the 23rd. That's for atoms, molecules, ions, or formula units. We'll also use 1 mole equals 22.4 liters, or 1 mole equals a certain number of grams. We'll learn about the grams and the mole in the next movie. That's molar mass. Now, answer using your response paddle for A, B, C, or D. Which of the following does not correspond to Avogadro's number? Make your choice. Get ready. Raise your paddles. Teachers, look. The one that does not correspond to Avogadro's number is C, 6.02 times 10 to the 23rd grams. Okay, so this is the end of movie 2. The next movie is movie 3 on molar mass demonstration. That's when you will use grams. End movie 2.